In our lesson today, we're going to be looking at systems of equations again, and this time we're going to see how we can solve them algebraically with elimination. We've in the past seen how we can solve systems of equations graphically and by substitution, but again, today we're going to focus on using elimination, which can be done when all of the variables are on one side, the same side rather, of the equations. And using the elimination method depends on the addition property of equality. Equals, when added to equals, are equal. If A equals B and C equals D, then A plus C has to be equal to B plus D. That's essentially the idea that we're going to be using here today. We're going to be adding equals to equals in order to eliminate a variable so that we can solve for one of the variables. Then we'll go back and figure out the value of the first one that we have eliminated. So let's take a look at our first example. All right, in this first example, the system is x plus 3, or excuse me, x plus y equals 3, and x minus y equals negative 9. We're going to solve the system of equations algebraically by elimination, and to eliminate a variable, we need to look for opposites. So I'm looking at my two equations in my system here, and I'm going to look and see if I have any opposites. X and x aren't opposites, they're the same thing, all right? 3 and negative 9 aren't opposites, they're different absolute values, but positive y and negative y are opposites to each other. When your equations have opposites, you can simply add the two equations together, and this will eliminate the opposites from the system. So if we go ahead and do this, x plus x is going to be 2x, y plus negative y is going to be 0, so that's eliminating the variable y, and it's going to equal 3 plus negative 9, which is equal to negative 6. So now in my equation, I don't have a y variable anymore since it's been eliminated. 2x is negative 6. To figure out what x is, I'm going to divide each side by 2, which means that x is negative 3. Now that I know the value of x, I'm going to go back and figure out the value of y by using the equations in my system. X plus y equals 3, and x minus y equals negative 9. In each of these equations from the system, I'm replacing x with negative 3. So negative 3 plus y equals 3, which means if I add 3 to each side, y must equal 6. And in the other equation, again, x is negative 3, so negative 3 minus y is negative 9. Add 3 to each side. Negative y is negative 6. That's the same as negative 1y. So if I divide each side by negative 1, y again is equal to 6. So for the solution, we're going to have the point negative 3, comma 6. When x is negative 3, the value of y is 6. In our next system of equations, 2x minus 4y equals 10, and negative 2x plus 6y equals negative 4. We're going to solve this system by elimination. So again, we're looking to see, do we have opposites in our two equations? And looking at the first set of terms, I can see that 2x and negative 2x are opposites from each other. So since my equations have opposites, I'm going to go ahead and add these equations together. So if you add 2x with negative 2x, that's 0. Negative 4y plus 6y is 2y. And it equals 10 plus negative 4, which is 6. So 2y equals 6. To get y, we'll divide each side by 2, which means that y is 3. Now to figure out x, use the equations in the system. 2x minus 4y equals 10. Y was 3, so 2x minus 4 times 3 is 10. All right, 4 times 3 is 12, so 2x minus 12 is 10. And if you add 12 to each side, then we know that 2x is 22. Dividing each side by 2 means that x is 11. Let's just make sure that x is 11 if we use the second equation in our system. Negative 2x plus 6y is equal to negative 4. Y again was 3, so negative 2x plus 6 times 3 equals negative 4. Negative 2x plus 18 is negative 4. So we'll subtract 18 from each side. Negative 2x is negative 22. And when you divide each side by 2, x is 11. So for our solution this time, x is 11, y is 3. 11 comma 3 is the solution to this system. In the next system of equations, 6x minus 7y is negative 4, and negative 4x minus 7y is 26. I'm going to solve this system by elimination, so I'm going to look at my two equations and look for opposites. And unfortunately, right now, I don't see any opposites. 6x and negative 4x aren't opposites. Negative 7y is the same as negative 7y, and negative 4 is not an opposite of 26. So the question becomes then, okay, how are we going to be able to eliminate one of those variables if I don't have opposites? And there's something easy that we're able to do, all right? I do see here that negative 7y and negative 7y are the same. What I'm going to want to do then is change one of them into a positive 7y so that I will have some opposites that I can eliminate. And so what I'm going to have to do then is multiply one of the negative 7y's by negative 1. But it's not that simple, okay? What I'm actually going to have to do is multiply the entire equation by negative 1. And it doesn't matter if I do it to the first equation or to the second equation, my answer will still end up being the same. So why don't we go ahead and take a look at this example then with the first equation. If we take that entire first equation and multiply it by negative 1, that's going to turn the first equation into negative 6x plus 7y equals 4. All right, multiplying by negative 1 just changes the signs of each term. The bottom equation we're going to keep exactly the same. Negative 4x minus 7y equals 26. And now I can clearly see that I have opposites with 7y and negative 7y. Since those are opposites, I'm going to add these two equations together to eliminate the y variable. Negative 6x plus negative 4x is negative 10x. 7y and negative 7y is 0, so negative 10x equals 4 plus 26, which is 30. Divide each side by negative 10, which means that x equals negative 3. So there's the x value. Let's get the y value then by using the equations in our system. So we're going to use the original equations. The first one was 6x minus 7y equals negative 4. X is negative 3, so 6 times negative 3 minus 7y is negative 4. That's negative 18 minus 7y equals negative 4. So we will add 18 on each side. Negative 7y equals positive 14. And if we divide each side by negative 7, then y must equal negative 2. Let's verify that by using the second equation in our system. All right, so we're going to do negative 4x minus 7y equals 26. X again was negative 3, so negative 4 times negative 3 minus 7y equals 26. 12 minus 7y is 26. Subtract the 12 from each side, and now negative 7y is 14. All right, what I'm going to do next then is divide each side by negative 7, which again tells me that y equals negative 2. All right, so for our solution this time, x is negative 3, and y was equal to negative 2. Negative 3, negative 2 is the solution. In the next system, x plus 3y equals 9 and x minus 2y equals negative 6. We're going to use elimination method again, so we're looking for opposites. And again, in this example, I don't see any opposites. X's are the same, 3y and negative 2y aren't opposites, 9 and negative 6 aren't opposites. So I'm going to say with my x's, though, since they're the same, I'm going to turn those into opposites by multiplying one of the equations by negative 1. So let's go ahead, just like we did with the last example, I'm going to multiply my first equation by negative 1. And when I do that, that becomes negative 1x, or negative x, minus 3y equals negative 9. The second equation we're going to keep the same. X minus 2y equals negative 6. And here are the opposites, negative x and x. So we're going to add the two equations together now. Negative x plus x is 0. Negative 3y plus negative 2y is negative 5y. And negative 9 plus negative 6 is negative 15. So negative 5y is negative 15. Divide each side by the negative 5, y equals 3. To get x, let's use the equations from the system. So the first one said x plus 3y equals 9. Y was 3, so x plus 3 times 3 equals 9. X plus 9 equals 9. So if you subtract that 9 from each side, then x must be 0. Well, let's make sure with the other equation. X minus 2y is negative 6. Y is 3, so x minus 2 times 3 is negative 6. X minus 6 is negative 6. And if we add the 6 to each side, yes, there it is. X is 0. So for the solution this time, it's going to be 0, comma 3. X is 0, y is 3. Our next system rather says 2x plus 5y is negative 1, and x plus 2y is 0. All right, again, I don't see any opposites right now because I'm using elimination method. I need opposites. So what I'm going to try to do is see if I can make opposites out of one of these variable terms here. All right, and now this x right here is the same as 1x. All right, and I can easily make opposites here with the x's if I multiply that second equation by negative 2. All right, because my first equation is going to stay exactly the same. I'm going to keep 2x plus 5y is negative 1. But if I multiply this entire equation by negative 2, I'm going to now get negative 2x minus 4y equals 0. Negative 2 times 0 is 0. That's nice. And now if I look at my x terms here, I see that they are opposites. So I'm going to add these two equations together. 2x plus negative 2x is 0. 5y plus negative 4y is just 1y, which is y. And it equals negative 1 plus 0, which is negative 1. And look at that. We already know the value of y. Y is negative 1. So let's see if we can get the x's by using the equations from the system. We'll start with 2x plus 5y equals negative 1. Y is negative 1, so 2x plus 5 times negative 1 is negative 1. 5 times negative 1 is negative 5, so 2x minus 5 is negative 1, which we can then add to each side of the equation. 2x equals 4, and if you divide each side by 2, x is equal to 2. All right, with the other equation in the system, it said that x plus 2y is 0. Y again was negative 1, so we can substitute that in. 2 times negative 1 is negative 2. X minus 2 equals 0. And simply add 2 to each side to get, again, that x equals 2. So for the solution to this system, x is 2, y is negative 1. 2 comma negative 1 is the solution. The next system says 6x plus 3y is 0, and negative 3x plus 3y equals 9. Once again, we don't have opposites at the moment, so I'm going to try to create opposites. And again, I can either do that with the x's or with the y's. It doesn't really matter here. So let's do with the y's this time. Since 3y and 3y are exactly the same, I'm going to change one of them into a negative 3y. So let's do the bottom equation this time. I'm going to multiply the bottom equation by negative 1. So I'm going to keep the top one. 6x plus 3y equals 0. And now the bottom equation, when I multiply by negative 1, I'm going to get positive 3x minus 3y equals negative 9. I have opposites here with 3y and negative 3y, so I can add these equations together. 6x plus 3x is 9x. 3y and negative 3y was the 0 that we eliminated, and 0 plus negative 9 is negative 9. Now to figure out what x is, well, just divide each side by 9. If we do that, then x is negative 1. Let's make sure by using the equations in the system, or let's figure out rather what the y is by using the equations in the system. So the first said 6x plus 3y is 0. X is negative 1. And then if we multiply 6 by negative 1, we get negative 6 plus 3y is 0. Add the 6 to each side. 3y is 6. And then divide each side by 3, which means that y is 2. All right. Let's make sure with the other equation that y is 2. The original equation, negative 3x plus 3y equals 9. X again was negative 1, so negative 3 times negative 1 plus 3y is 9. 3 plus 3y is 9. And now we're in good shape. Subtract 3. 3y equals 6, which if we divide each side by 2, y again, or by 3 rather, y equals 2. So for our solution this time, x is negative 1 and y is 2, negative 1 comma 2. The next system that we're going to look at is a little different than all the previous systems that we've looked at. We're again going to use the elimination method, and the system says 2x plus 3y equals 10, and 5x plus 7y equals 24. And looking here, it's very clear to tell that there are no opposites anywhere with the two equations. And so what I'm going to have to try to do is create some opposites by doing multiplication. So let's suppose for a moment that we wanted to try to eliminate the x value. All right. If I wanted to eliminate the x value, I'm going to need to make opposites here. All right. And if I multiply something by 2, I need that to be the opposite of 5, which is going to be negative 5. But 2 times 2 is 4. 2 times 3 is 6. I've gone over the 5, so that's not going to work. And if I wanted to try to eliminate the y's, all right, well, again, I need something to be the opposite of positive 7, which would be negative 7. But 3 times 2 is 6. 3 times 3 is 9. I've gone over 7. So, oh man, I'm really in a jam here. Okay, so what I'm going to actually end up doing here is multiplying both equations by something in order to create opposites. So for this example, what I'm going to do, I'm going to try to eliminate the value of x. All right, I want to eliminate x, which means I need to make opposites with their coefficients. 2 and 5 have a common multiple of 10. So for one of my x's, I'm going to need a positive 10, and for the other one, I'm going to need to have a negative 10. So what I'm going to do is I'm going to make my first x up here, this 2x, I'm going to keep it positive. So I'm going to multiply this equation by 5. But my next equation, this x, I'm going to need to be negative 10. And so I'm going to have to multiply that by negative 2 in order to make that happen. Let's see what happens to our system when we do that. 5 times 2x is 10x. 5 times 3y is 15y, and 5 times 10 is 50. Underneath with the second equation, if we multiply by negative 2, negative 2 times 5x is negative 10x, negative 2 times 7y is negative 14y, and negative 2 times 24 is negative 48. And now I can see that I've created the opposites. Okay, so sometimes, all right, if it's not easy to just make opposites by doing something to one of the equations, you might have to do something to each equation to make those opposites. Let's add the equations together now. 10x plus negative 10x is 0. 15y plus negative 14y is 1y, which is exactly what we want. And 50 plus negative 48 is 2. Y equals 2. Let's get x now by using the equations of the system. The first was 2x plus 3y equals 10. Y is 2, so 2x plus 3 times 2 equals 10. 2x plus 6 is 10, so if we subtract 6 on each side, 2x is 4. Dividing each side by 2 means that x is 2. Let's make sure with the other equation, 5x plus 7y equals 24. We had a y value of 2, so 5x plus 7 times 2 is 24. 7 times 2 is 14. And if we subtract the 14 on each side, then 5x equals 10. Divide each side by that 5, and there it is, x equals 2. So for the solution to this system, x is 2, y is 2, 2 comma 2 is the solution. So once again, this one was a little different. I had to multiply each equation by some value in order to create the opposites, and that might happen sometimes. So always look, is it easy to make opposites by doing something to just one equation, or am I going to have to do something to both equations?